So thank you everybody for showing up today, and as you've probably been noticing, we're enjoying our share of technical challenges, but right at this minute, everything looks like we're good to go. So, my name is Melissa Davis, and I'm the managing director of a nonprofit called New Power Tour, and we've kind of been helping with the background information in this fact sheet that we have back here. And, I'd like to introduce the Keweenaw Renewable Energy Coalition. It is a group of entrepreneurs and developers and a 501c3 who are all in the same boat in regarding to emerging renewable technologies. So we decided to form a think tank and pool our efforts to create the preconditions to bring renewables onto the market in the Keweenaw. We have Sam Lockwood, who is a treasurer, Tom Tikkinen, and Elmore Reese, and Craig Marley. And we also have Emily Priota, who is our student liaison, who isn't here today. We formed earlier this year and incorporated this summer, and we're in the process of getting our 501c3 designation. So today we'd like to bring to you presentations of information that use the latest data, solid science, and market-based technologies. We're here to bring that to the state of Michigan in the hopes that Michigan will build a policy that supports the residents of the UP in building a truly sustainable energy strategy that provides a Michigan solution. It's KREC's intention today to create a respectful and thoughtful environment so that we can have a coherent dialogue about the issues and ramifications surrounding the UP's energy situation. So I'm glad you're all here and to make that happen. The situation is causing a lot of tension, and there are several time-sensitive pressures. So a short overview is in order, starting with, here in the Keweenaw, we pay among the highest electric rates in the nation. And thanks to Abby for making everybody aware of that. Otherwise, it was just, I think that I myself was just going along business as usual, assuming that it was par for the rest of the country. We do definitely have the highest rates in the state of Michigan. So, time-sensitive pressure number one, Presque Isle Power Plant is scheduled to go offline. The Federal Energy Regulatory Commission has requested that it stay open as a system service resource. And right now that cost is being scheduled to be allocated to UP ratepayers at an estimated $116 million a year. So that's almost nearly $10 million a month just to keep us in a holding pattern with none of the changes that are proposed solutions coming our way. And Senators Levin and Stabenow have proposed a 2-month delay on this increase. As you will see in the following presentation, the Upper Peninsula is renewable resource rich. We have a National Renewable Energy Lab graded outstanding wind and decent solar at 4.5 kilowatt hours per day per square meter. Plus, solar technology keeps improving efficiency at such a rapid rate that it has become the cheapest source of renewable energy. Governor Snyder's energy policy advisor, Valerie Brader, stated that as a solution for UP electricity needs, renewables won't work because wind and solar are intermittent. What she and the administration are leaving out of this equation is woody biomass, a reliable source of uninterruptible or callable electricity. So how would we pay for this sort of a generation project? There are two avenues that you should be aware of. One, the Department of Energy has a program in place that offers 30% federal business energy investment tax credits. And there are third-party investors who are looking to take advantage of this program. This project offers them that opportunity. The program, these tax incentives are set to expire in 2017, so that makes it a time-sensitive thing. If we're going to get it together and take advantage of that program, it has to be soon. And nobody wants to make rushed decisions, least of all me or Keweenaw Renewable Energy Coalition. So it's going to be the pressure of being thoughtful and deliberate, yet still making the timelines and the deadlines. Governor Snyder, the second avenue, is that Governor Snyder, in a forward-thinking and brilliant act as governor, signed into law last December the Michigan Invests Locally exemption, or the MILE Act. What this means is that the average Michiganders are now able to invest in local business. It used to be that only accredited investors were eligible to do this, people whose income exceeded $200,000 a year or their assets were over $1 million. That's opened up. Now, anyone can buy into local projects that they believe in. The term for this emerging investment climate is values-aligned investing. That is, being able to put money into businesses that align with your values. So a person can now invest as little as $50 or as much as $10,000. The total allowance for each project is up to $2 million for audited crowd equity financing. So this means it would be possible for us to own a piece of our electrical generation, wind, solar, and woody biomass, if Lansing will work with us on a Michigan solution. This wouldn't follow the traditional investor paradigm. If you were to invest, you wouldn't see an immediate financial return. What you would see is an improved local economy. You would see jobs created. You would see cheaper electricity rates. You would see things happening around you that align with local values. Then after 7 to 10 years, conservatively, after the projects go from the red to the black, you would see an annual dividend check. There are experts emerging in this new economy. We've been working with one consulting firm called Revalue Reconsider, a financial planning and investment management service for conscious investors. They are unpacking the MILE legislation, and they have an introductory white paper that the MEDC and Michigan State University provided funding for. They're interested in coming to the area and coaching us through the process if this is the direction we choose to go. So, we have a network, and we have resources. Our first speaker, Asko Ojaniemi, has been a forerunner of bioenergy in Finland since the 1970s. We're very fortunate to have his expertise on KREC's plan to provide woody biomass backup for all the wind and solar we could possibly harness to meet our needs. Woody biomass, or bioenergy, as I'm going to now refer to it because the Finns do, in our country, bioenergy means a whole host of different renewables, but in Finland, bioenergy refers to woody biomass for energy wood. Woody biomass is relatively unknown to most residents of the UP, even though there are applications of it in place. There's a fundamental debate about whether we have the trees required to fulfill our electrical requirements. So here's where forest management needs to be brought up. Finland's forest management practices have increased the amount of forests they have. They have more forest lands now than they did at the turn of the century because of their sustainable harvesting techniques. Finland's land mass is roughly equivalent to the state of Michigan total. And the UP has way more forests than Finland does. I'd like to give you a really nice figure to substantiate that with, but I don't have one. Somebody else maybe will be able to provide that. Bioenergy, or energy wood, in no way competes with any other logging industries or economies. It uses the slash or forest residues that are left on the forest floor after logging. Or, in the case of private landowners, and here's where the education really needs to take place. A practice known as TSI, or timber stand improvement, allows a forester to come through a property and mark stands for thinning. Taking out small diameter and sickly trees, using equipment with a small footprint to harvest the trees, waiting until the leaves fall off the tree so that they can mineralize the soil, and then returning the ash after the power production back to the soil to also mineralize it. And another thing that they have in Finland that it would be well for us to adopt is forest landowner cooperatives. So, for example, a team of 4 foresters will work to harvest, bring trees to a drying terminal, chip them after they've dried, and deliver them to locations that use woody biomass for heat and electricity. This model creates income for the landowners and well-paid jobs for foresters and timber harvesters. Now, I have one final point to make before we bring Asko on to show us his PowerPoint. Because our plan is responding to the need for backup generation of electricity, time constrictions have made it challenging to address one very important and integral point to the use and production of electricity from bioenergy, and it is a law of physics. For every unit of electricity produced through combustion, there are 2 units of heat. If you really want to see this project take off, you will be thinking about how to use the heat. So far, we've just been in mode of providing electricity, but seriously, using the heat is absolutely an essential part of it. And it should be easy to think about this with winter on us for 7 months of the year, and Winter Storm Asko coming today. Hands down, the smartest thing would be district heating. That would be providing heat and electricity and making them cheaper for UP residents. But that would require such an overhaul of infrastructure and such massive cooperation on the part of whole populations that even though it's the smartest thing, personally I've kind of mentally taken it off the table because that just seems like such a huge undertaking. But another thing that can be done with it is to add value. And so I would like to introduce the concept of one great value-added application from the heat produced from small-scale woody biomass production. That is a tasteful and not tacky water park. The hotels would probably really like it, and of course, they would be among the first to be solicited for crowd equity financing. The best case scenario would be a municipal involvement in a project of this stature. Imagine if the average admission to a water park is between $30 and $50 a day, and the biggest cost in a water park is heat, which would be free as a byproduct of combined heat and power. Imagine how much that revenue stream will bring down the cost of generation, and therefore bring the return on an investment that much sooner. I would like to own a piece of that. So that is food for thought. Nobody else is going to be talking about that today. I just wanted to tell you about that. So let's start our day's presentations. I would like to introduce Asko Ojaniemi. Ojaniemi is how you pronounce it in Finland, not Ojaniemi. So, Ojaniemi. He is the managing director of Benet Oy, a bioenergy consulting firm from Finland. This is Asko's 3rd visit. Most recently, he was here during FinFest 2013 as a guest on the Bioenergy Roundtable at the Business and Technology Forum. Please join me in giving him a hearty welcome.
Good morning. It's nice to be here once again. And I was just last week touring Northern Ontario, more or less the same message. We were a bigger Finnish group there and looking at the possibilities or utilizing local resources in those cities and towns in Northern Ontario. I'm telling about a bit of Finnish experience and a bit trying to relate it to our Michigan landscape resources. They are very, very much similar. Basically, the traditional heating and a bit forest ownership and legislation, they are different, and there are the differences. So if the problems were only commercial and technical, so we could solve them very quickly. But we have started the biomass and also the combined heat and power development decades ago. So we have developed the tradition, and nowadays setting up new project is far easier. A bit, not too many words about what we do, but we are basically doing different work to promote renewable energy, and the most important renewable energy in Finland is bioenergy. The bioenergy, or different forms of biomass, they will be the most important renewable source in whole Europe. There's a lot of talk about wind and solar, and in some countries those are important, but in total in Europe the biomass will be the backbone of renewables. We do the regional and municipal energy plans, but also very practical, setting up district heating schemes, new combined heat and power schemes with industries and with municipalities. The forest fuel is #1 in Finland. We have tried short rotation, we have tried agrofuels, but they are not close to compete forest fuels in Finland. So it's much more understandable that straw and different agro residues are very competitive in Spain. After harvesting season, there's a dry season, and you can get guaranteed dry agro residues after harvesting. In our harvesting time, we are harvesting cereals, so most likely there will be rainy and winter coming very soon, and it is not guaranteed that we can get dry agro residues every year. In the mills, we are coming mill residues from those are utilized mainly in the mill internal processes. We are doing international projects, mainly European co-financed projects, so then transferring the technologies between countries, mainly within Europe. Sometimes we could include one of our visits here also in one European project, so allowed to make a study tour outside Europe. Then we came here. But our projects are fuel supply, district heating, or combined heat and power. We do not have any conventional biomass power plant running at the moment. And the clear reason is that we don't have feed-in tariff for big biomass plants. They must compete together with coal and nuclear plants on a Nordic electricity market, where you get paid 3-4 cents per kilowatt hour when you sell power to the market. There are feed-in tariffs for basically for wind energy in Finland, and government is paying double compared to the market price of the electricity. But biomass plant, when they are combined heat and power, they get paid for heat and electricity, and they can run virtually without subsidies. There's one reason that the biomass counts 1/4 of all energy, including traffic in Finland. So government does not have money to pay feed-in tariff for that big amount of energy. So the newcomers are getting at the moment support, but biomass is business as usual and should already stand alone. District heating is common, and it's now basically every city, every town has district heating network. It is practical form that it's not handy to use locking residues individually in each home, but when you have district heating plant in the village, so you can use local resources for heating. If it goes individual heating in Finland, in new houses nowadays, most likely it is heat pump, ground source heat pump. But when you can option to connect to the district heating network, then you can use local woody mass for heating your house. All cities where it is commercially viable, without these feed-in tariffs, so we don't have really the small CHP units running. So it's 3-4 megawatt is typically the lowest level which is commercially viable without support. In Germany there are hundreds of 1 megawatt or below 1 megawatt plants, but they enjoy the feed-in tariff about 17-18 cents per kilowatt hour. And the other feature is that nowadays the small new schemes, they are typically private. Municipalities are, they feel that their obligation is to arrange that the citizens can get good heating service. It is one of the utilities, like power, sewage, water and heat. They are all on the same level, but municipality need not to own that, just make sure that the service is available on reasonable price. And there are some dots where we have heating plants, so they are everywhere. Because they are combined heat and power, the size of the plant is very much determined according to the heat load. In my hometown, in very central US plant, there are 2 power plants. Old one is generating 90 megawatt power, 200 megawatt heat. New power plant is 170 electricity and 200 heat. There is an option that they can run it as a conventional power plant and generate 240 electricity if they don't sell heat. But so far, very rare occasions, electricity price has been so high that they have been running conventional condensing power. Mainly they are in combined heat and mode and sell heat and electricity from the plant. But there are all sizes. It's a heat entrepreneurship concept that there's one contractor is taking care of fuel supply, heat plant management, even ownership of plant, and sell heat by meter to some industrial buildings or small municipalities. Those are 500 units established. So there are many business models how to run it, because they like to have the district heating in their own hands, because it is money maker to the big cities. Yeah. Because it's more efficient to have large buildings, so you can get a lot more customers per pipe meter in the big city. So it is good business to the municipal power companies, and that's why the big ones are typically publicly owned. Different motivation. Finland was very oil dependent and started to be a bit worried that what happens if oil price starts to fluctuate, and then started to develop the peat, that's the local resource, and then shortly after peat started the development of other renewables than mainly wood. The natural gas was favored at one time. Nowadays, natural gas plants has been already replaced by biomass plants. And here are these motivations. It has varied, but the security of supply, to diversify the energy balance, was a first motivation to start looking at this, and government started not to putting money on investments and support, but putting money to the research and development. And then came the rural employment issues. The agriculture was a big change, so 100,000 jobs were lost in agriculture. Production is still possibly the same level or more than before, but it's in a bigger farms and more efficient. So there are a lot of workforce was available in countryside, and energy gave jobs for part of those. Forest management issue to guarantee that the forest industry is very important in Finland. So to guarantee that commercial timber is available, so forest should be managed, and very extensive management started in the 60s, and energy wood is something that it was encouraged to thinnings, taking small diameter trees so that the remaining trees grow faster to commercial size, and more commercial pulp and sawmill timber will be available for the industry. So in Finland it is no conflict between industry and energy sectors. That it's good that energy sector is helping in the forest management, so that there's some money is paid for those small trees below pulp size, and also the tree species which are not have any commercial use. But climate change is a latest motivation, and it is a driving force throughout the Europe nowadays. District heating, that gives an opportunity that if there's a possibility to place a power plant near the town or within the town, so you can get the town heated without additional fuel, virtually. So it's almost the same, that instead of cooling to the air or cooling to the lake, you are using the houses for cooling sink for the power plant, and there's that is at least it is resource-wise, which is one of the words which is widely used nowadays. So getting more done with resources, even if it is renewable, but still use renewable resources wisely. It can be done technically, and but the other options is that you start building gradually, small heating plants here and there, groups of buildings, and eventually, when they are enough, so you one day connect and build a power plant. So there are options that see that how it develops. Okay, these are small ones which are still picked up, but these are all private examples of private where we have been organizing the competitive bidding and getting the operator and design the network, but just to show that changing from fossil fuel to renewables, so you save environment and you save money directly. And because it is district heating service provider, so their household need not to build own boilers, having heat exchanger, and enjoys the heat for the next 30 to 50 years. We don't have many big district heating references recently because all bigger has been built already. So these are quite small ones. Here are a few examples what kind of this is. I tried to pick examples which are not too far from Hancock size. That there's an Isam with 22,000 inhabitants. That is one of the last a bit bigger towns which switched to from individual heating to district heating. They have this type of public fluid aspect boiler, accepting very wide range of woody residues from sawmills, bark, sawdust, possibly peat, logging residues, whatever are available in the region. And this is then back pressure. There is a bit extraction that you can adjust the temperature. This is the network temperature, but mainly the load is district heating network. The parameters, not very big plant, but still over 500 degrees C. So it's about fairly the same levels than in coal-fired plants. It's a 48 megawatt fuel capacity. Yeah. A bit bigger city. There's a plywood mill in the town, and it's situated near the plywood mill. So this mill is providing steam to the plywood mill and heat to the network, and of course making power. About same parameters, 90 bars, 500 plus degrees. And there are additional boilers in the different parts of the network to cover the whole. This is not enough to cover the whole needs of this town. But the district heating networks can be quite extensive, 73 kilometers when you count all the branches to the individual houses. And very wide range of residues what you can find in the region. Of course, first are the mill residues nearby, all kind of trimmings, grinding dust and that kind of material from the mill, but then for the outside also accepting and the plant decided that what kind of material is likely there will be over the lifetime of the plant. This is already very close to the size which could serve Keweenaw is something like 10,000 inhabitants, and there's a small, quite new plant, a couple of years old. And because they're small, so they're a bit lower parameters, so that to keep the investment cost on reasonable level. But when you a bit drop in the pressure, you can reduce the investment cost, but the ratio between electricity and heat is also reduced. So there's a boiler house, there's a fuel receiving, fuel handling, it is crashing, there will be metal detectors, crushing of big particles if there comes oversized particles within the fuel feeding, and then fuel gas handling. Handling, it's electrostatic precipitators, ash silos, and turbine hall. It's a photograph of the same plant. Here a few figures, something which I have no idea what could be the real and an optimum size for Keweenaw, but I make some that if it is say around 10 megawatts, and if it is a power only plant running most of the time with full capacity, the Finnish plants are running according to the more or less according to the temperature that they are running full capacity if the temperature is something like -5 or below, and then there are coming additional boilers to help them. But but in summertime they are running on partial load. But if it is power only, so it can be running all the time, the fuel amount will be slightly bigger, and it will be something 10 truckloads, depending on the truck size, 10, 12 loads a day, coming, blocking residues, non-commercial species, dead wood, tree tops, branches from the logging site. If decided, so if there are old sawmills which have heritage piles of decayed back or residues, so you can gradually feed those into the boiler if they are not too wet. If you have to clear the abandoned agricultural lands are having a lot of bushes, all those are good material for energy. And in Finland, so the commercial size wood is not used for energy. There have been enough residues. Even we have a very high portion of energy from wood. I have here a bit, in parentheses, there's a turbine with extraction. That is the idea that if the power plant is not too far from the town, and if you have extraction turbine, you can mainly do the condensing power, but still if you have heat customers nearby, you can do some heating also. Also, either it is industry or it is some bigger heat customers. The plant is not a big employer. It's typically 2 people per shift running, but the fuel supply, there are really, fuel must be collected from the forest, so there are the logging, forwarding, shipping, hauling, and organizing the whole thing. That requires people, typically done by contractors, not as a power plant homework, but fuel is bought, delivered to the plant, and these are then trained people doing delivering the fuel to the plant. Some advantages, so there, of course, this area is end of long power line, so if you have own power plant, biomass power plant, so it is weatherproof, it is solar energy, but it is stored in the form of biomass, so it is available on dark days or windy days or non-windy days, it's always available. So it gives direct employment, it gives indirect employment in the area. Fuel cost is mainly salaries to local people, so the money stays and goes around in the local economy, several rounds. And if it is used for forest management, encouraging better forest management, so there can happen the same thing that happened with us, that we have standing stock in our forest is much bigger than it was in the 60s when the more intensive forest management started. And here, basically that if forest is managed and used, so it is also a CO2 sink. You take material out of the forest. What is used for energy, it is something which would rot in the forest anyhow, so it's CO2 neutral, but when there is more forest growing more timber growing in the forest, so that is working as a CO2 sink, and then coming timber for construction, where it is carbon storage for decades. So it's quite good positive cycle. So if you make a power plant, so it's a good site, it's easier to build if you have a good solid area. If it is something very soft, so you have to put piles and anything. So, but cooling source, you can get with the same fuel a bit more electricity if you can cool it properly, and cooling by lake or river is more efficient than cooling towers. Grid connection is important, and then that it is somewhere preferably so that not trucks need to come through the city, but on the access from the main roads. And then comes power sales. In our case, power plants can sell to anyone they like. Here is legal framework is a bit different. But if you have the heating and cooling plant, so it's a bit more critical. You should be, those criteria as before are still valid, but now you should be close to the town and the heating network also. It's to finding the site is a bit more difficult work, but typically can be found. The turbine does not know how the steam is made, so okay, so that part is very conventional, same as anywhere. Only in the boiler island, that must be designed according to the expected or foreseen fuel mix in what is available in the area, what is thought that it can be the most economical mix. But boilers can accept very wide flue gas cleaning. Electrostatic precipitator is often enough, but then there are other options. If you want to go even lower is fabric filter is a bit more efficient in capturing solid particles. NOx is not the main problem when you are not burning green leaves and needles. And you let the material season for a while in the forest, so the needles are dropping, so then very little nitrogen is coming to the plant. But okay, there's a catalytic reduction if that is required by authorities. There's a possibility use also flue gas condensing unit, which again will improve the efficiency of the plant, but the result is then you need a heat source where you put it. Options. So if it looks like that the fuel supply will be clean whole trees, clean wood residues. So a great boiler is fine, can be designed for working nicely, or public fluid bed. If it is all kind of locking residues, very much varying material, varying moisture, so public fluid bed is a good one. And if there's a coal option or option that there's sometimes could be very big share, very dry material coming into the boiler, so then picking the circulating fluid bed technology for the boiler. But in small ones, it's a BFB or grate are the dominating technologies. BFB has been dominating on the small power plant boiler technology in Finland for a few decades now. This is our hometown plant, and here are some examples that in Äänekoski, that's together industry and city are working closely together to generate waste heat from the industry, and the industry and city having joint power plant. Multia, same thing in smaller scale, sawmill and municipality having joint power plant, or joint heating plant. And here are this is a real size business. There's small diameter trees from early thinnings, logging residues, different methods to collect it, stump and root wood from final harvesting, good fuel, and typically left to season for one year, so that the rain is partly washing sand. Cannot use chipper for the root wood. It's stones and sand, but you have to use crusher for that one. Other clean materials you can use chipper. It's taking less energy to grind them. And here are pictures that doing harvesting, falling shipping, transporting, and from young stands, so then the remaining stands start to grow and are faster to commercial size when you do the cities. And this social benefits is mainly coming from the salaries which are coming to the area, and the stumpage price. Okay, stumpage price goes to the landowner, but even that is quite small in energy wood. It is 0 to something, and the old money is local. But in our region, 200,000 people, so this is important sector to keep employment, and exactly keeps employment in rural areas. Okay, we are here, so then, there are a lot of issues where we cannot help, but in these the technical issues and transferring experience and our own sharing our experiences, there we can be of help. But there are many issues that clearly must be solved locally, and the best experts are locally. But in early phase training and giving examples, so I guess that whatever size plant you wish to build, so we can find some example where you can take a look and see that, okay, this is good for us. And here is the Iisalmi before and after district heating. Okay, thank you.
Thank you, Asko. Next on our agenda, we have Rich Vanderbeek. He's going to be Skyping in.
Yes, questions.
Some people would really like to ask some questions. Yes.
Could you just back up one slide, because I couldn't see the before and after. One was a little closer. Yeah. Let's see. Is the point that you're
Yeah, the whole individual stacks, smoke coming in from here.
Oh, that's not
And in the after picture, there's one power plant controller stack outside down one area.
So that's not snow, that's smog.
That's not.
Oh, that's a big difference. Just look like a normal.
Yeah.
Thanks. I interrupt my dean. Welcome, so is there competition between the logging residue that goes to power versus what goes to wood pellets? Because I know pellets, there's a big market in the EU right now for pellets.
Not really. Pellets are, they prefer the dry residues, and okay, sawdust quite often goes to the pellet. They need it wider, so they have a bit better paying power than energy combustion units. So not really conflict that it is the brown material goes for white chips, goes for pellet or pulp mill, and the bark and other materials go for combustion power plants.
Are small private landowners a part of the mix for the supply? And if so, are they incentivized in some way or not? What types of ownerships contribute to the supply of this biomass, and how is it incentivized?
Mainly private smallholders.
Maybe private.
We are, most of the forest area is private and owned by farmers. I think I'm bigger than average forest owner, and I have something 200 acres.
How do you distribute the heat in all those homes? Did you have to dig up the streets and put pipes in, or?
Yes, they are circulating two pipes, main pipes, and then branches to houses, typically under the
pedestrian areas or the street shoulders.
Have you thought about thermal density? How many therms are necessary per square mile to make district thermal economically viable?
It is something like if you have, let's say, silent capacity about 500 kilowatt to 1 megawatt per network kilometer. So something like that is reasonable in our case. So that 1.5 megawatt per mile or 1 megawatt per mile distance.
So that's a lot more dense than here.
It's it covers the downtown. Easily can be achieved in downtown area, but then if there are, say, housing areas and there's a big distance without customers over there, so they're sometimes not the most attractive customers to the heat supply.
And what do you sell the heat for, dollars per therm?
It's not very difficult. The units are difficult. The metric units, so district heat is around 70 euros per megawatt hour, 60 to 70 euro per megawatt hour, because it is typically a bit lower and a bit higher in smaller cities. So then you get the heat without own investment.
How do you integrate with photovoltaic, the solar power, and wind generation, especially the PV part of it? And does a biomass generation plant, does it handle those types of inputs differently than a coal-fired or gas-fired plant?
Yeah, it's a grid order. It makes the integration that which one they are running. That if the solar is very cheap, so okay, then lower it. Then if there's overcapacity situation, it takes in the solar whenever it is available.
I guess I'll put it in a different way.
Yeah.
It's a sunny day in Keweenaw. We have a lot of PV here, and we're putting a lot of generation of kilowatts back into the system. Does the biomass system can it back off the amount of power it produces better than a coal or gas fired?
Yeah, it's typically it's with one boiler, so the range is from 20% to 100%. Capacity is adjustable, but very much it is. If it is CFD plant, so then it is running more or less according to the heat load and taking other sources in for power when needed.
So it was a sunny day in the winter time, it would be more of a challenge.
Yeah.
You were also
Yeah.
producing heat.
Yeah, but if there's a power purchase agreements and some support on the PV, so that they are independent actually then.
Can you build a power plant without cogeneration?
Yeah.
And then add cogeneration later?
Yes, that is the extraction option. If you make then you put a bit more money on turbine so that there's an extraction option that whenever there's no heat load, you can run it as a conventional plant. Actually, the latest power plant in our hometown, Keweenaw plant, is exactly such plant, but it is what we call the condensing tail there is used when the power price is attractive, so attractive that you like to do the condensing power. That means that in our case, if the market price in Nord Pool is 8 cents or more, they start to run it as a conventional power plant. But if the electricity price is lower, they do cogeneration and try to make money by selling heat and power.
I want to ask you a question about the role of
Not not big effect. There are some that as a precaution we are not collecting logging residues from very sort of poor soils, growing pine. So two reasons actually. That, nutrient balance is one. The other reason that when in the pine forest, so the yield of logging residues is very small compared to the spruce stands. But basically that if you let the logging residues to season in the area, needles are dropping, leaves are dropping. So most of the nutrients are in the leaves and needles. So that is already recycling. This ash is about 5% of the solid weight on the material, and we are recycling ash to the forest. And all the other nutrients except nitrogen is left in the ash. Nitrogen will be volatile and it's going to burn. All the other nutrients, and especially on the wet soils. Wet soils are rich in nutrient or nitrogen, but lacking for other nutrients. So in wet soils, the wood ash is very good fertilizer if you bring it back to the forest.
You mentioned there was no feed-in tariff, correct, to support the industry, is that right?
Yes.
So
it's a very small plants. If you have 1 megawatt plant, so you have possibility for small feed-in tariff in Finland.
Are there any additional supportive policies that are in play to help support the industry?
Very small tax reliefs are, and small. On a heating sector, there is a carbon tax on coal, but it is not applied on power sector. So the power, again, European ruling that we are not allowed to tax power fuels, only the electricity is taxed.
No use of mandates or anything along those lines?
No.
I think we're at time now for our
Yeah.
next.
One last question.
Okay.
Are you, in Finland, if you distribute power or you distribute steam, are you a regulated power utility or steam utility?
No, you can sell power even when you like. But the transfer network, they are regulated. But they transfer your power to anyone you like. Among Nordic countries, you can, small or big, you can, you have to find your own customers and sell. Either you sell directly or you sell through the Nord Pool exchange that you make offering for next day, and at the 2 o'clock every afternoon you know what is the tomorrow electricity price for each hour. But of course there are financial tools that some part of the production, big producers are guaranteeing some part of the production. I will be here around, so if there are any further questions, so please come and talk to me.